Today we're going to talk about what polynomials really are. So a polynomial is a monomial, mono like one, so a number variable or a product of a number of variable, or a sum of monomials. So a polynomial function is a function of the form, and it gives this form. So a sub n times x to the n. So that's the first coefficient times x to a value of a coefficient, plus a sub n minus 1, so the next coefficient times the next variable with the next lowest power, and so on. So here it's like 2x to the fourth, there is no x to the third term, minus 8x squared, plus 5x minus 7. So some words here that we're going to talk about: monomial, polynomial, standard form, degree, leading term, leading coefficient, and constant. So monomial we know means one, right? Mono, one, singular. So a single term would be a monomial. I'm going to jump to, we'll stick with polynomial. So polynomial, poly meaning many, right? So multiple terms combined with addition or subtraction would be a polynomial. So standard form is how you're arranging those terms. So here, terms are arranged with exponents in decreasing order. So for example, this polynomial is not written in standard form because the exponents did not go from highest to lowest, but when they are arranged in that way, it's considered standard form. The degree is the power, it's the exponent. So it's the highest exponent of a polynomial is the degree. The leading term. So the leading term is the term with the highest exponent. So when it's written in standard form, it's actually the term that's in front. It's the line leader, because when it's written in standard form, the highest power goes first. So leading term, term with the highest exponent. The leading coefficient. So now that would be the number in front of the term with the highest exponent. So we're going to go up here, they're yellow. And then the constant would be the term with no variable at all. So a constant is when it's just a number with nothing else going on. All right, so here we have a bunch of standard form, the way they look, fancy-wise, but here's some examples. So if we just have a number, right, no variable at all, we call that a constant. And the degree is 0. There's no exponent on our variable because there is no variable, right? It would have had to be negative 14 times x to the 0 because x to the 0 is 1. That's the only way the x goes away. If you have something with an x to the first power, that would be a degree of 1, and we would call that linear, right? Linear functions all have exponents of 1 for the variable. When the power is 2, no matter how many terms there are, that's a quadratic. Talked about quadratic for many years now. Third power, right? Third degree was cubic. And then if you remember from our lesson the day before, the fourth power is quartic. Like a quarter, 4 quarters in a dollar, 4 quarters in a whole. So some things about polynomials. Right? Not everything with multiple terms is considered a polynomial. So it cannot have division by a variable. So there cannot be any variables in denominators. You can't have any negative exponents. That would essentially put the variable in the denominator. You can't have any decimal exponents. All the exponents have to be whole numbers. And it can't go on forever. So if you see a plus ... it's not a polynomial because that means it goes forever. There has to be an ending point plus some last number there. So for example, 1, we're going to determine if it's a polynomial. If it is, we'll write it in standard form and identify the degree and leading coefficient. So here I have, let's check our powers. Whole number, positive. Whole number, positive, that's a 1. Whole number, positive. Whole number, positive. There's no variables in the bottom. I don't have any dots, right? So this, I believe, would fit the definition of a polynomial. So the highest power here is 5. So we could either keep this as negative x to the 5th over 8 or negative 1/8 x to the 5th, which I think is what you'd probably be more used to seeing. So that would be our leading term because 5 was the highest power. All right, so I got rid of that term. The next highest power is the 4. The next highest power is the 2, and that was a positive in front. Then I have power of 1, and then I have my constant. So this would be my polynomial in standard form. So its degree, right, the highest power that we saw was 5. And the leading coefficient, which I'll usually abbreviate to LC, the number in front of that term was negative 1/8. Right, we don't include the variable in the leading coefficient. For B, right, positive whole number, negative exponent, so no, not a polynomial. So we don't have to put it in standard form because it's not a polynomial. So here's one for you to try. You can pause. Answers are posted on the blank notes in Google Classroom. So let's talk about odd and even degrees. So we look at the power of a function, the exponent of the function, its degree. And if it's even, it's going to look one way. And if it's odd, it's going to look a different way. So even, you're going to have both sides going in the same direction. And in odd functions, you're going to have both sides going in opposite directions. And what this allows us to do is it allows us to know what the ends of the graph will look like based on the degree. Even more than that, we can tell if they're both facing down, right, or both facing up, or if it's going up from left to right or down from left to right by also using the leading coefficient, if it's positive or negative. So let's make a little chart here. A positive leading coefficient, a negative leading coefficient, even degree, odd degree. So when it's positive and even, they're both going to be opening up, right? Something's going to happen in the middle here, but the ends of the graph, the end behavior, they're both going up to positive infinity. So as x goes to positive infinity, the arrow was going up to positive infinity. As x was going to the left to negative infinity, the graph was still going up to positive infinity. And negative and even would look more like this. They're both going to go down, right? Something that's happening in the middle there, but on both ends, they're going down to negative infinity. For odd degrees, odd equals opposite. So they're not going to be the same ever. When it's positive, it's going to look like a positive slope. So that means to the right, it goes up, and to the left, it goes down. Whereas a negative leading coefficient and an odd degree, they're still going opposite directions, but now to the positive, we're going negative, right? To the positive, we're going negative, and to the negative, we're going up to positive. And you don't have to put the plus sign on infinities. If it's positive infinity, you could just write infinity, or you can write positive infinity. Both mean the same thing. So using example 2, using the graph, answer the questions about the key features. So we can look at the end behavior here. So to the right, it was going up. To the left, it was going down. So because they were going in opposite directions, I would say that this is odd, because odd equals opposite. And because it's going in a positive slope fashion, right, going up to the right, it's positive. And honestly, I do believe you can look to the right always, and that will always be the sign. So if it was even and positive, it's up there. If it's odd and positive, it's up there. If it's even and negative, it's down here. If it's even and negative, it's down here. Even and odd and negative, it's down here. So the right side of the graph will always tell you the leading coefficient. So you go ahead and try this one. You can pause. The answers are posted in the blank notes in Google Classroom. So for example 3, we're going to describe the end behavior of each function. Now instead of the graph, we have the actual function. So I need to find the term with the highest power. So this is x to the fourth, which is even. And it's negative. So even and negative is both down. If you want to sketch your little graph there so you know, but negative and negative. For this one, my highest power is to the fifth power here. So that is odd for the fifth power, and it's a -2. So this is going to be going down from left to right, which means negative on the positive, positive on the negative. Here, oh, not in standard form, my highest power is 2, so that is even. And the 4 is positive. So this is going to be going up, up. So positive and positive. And my last one, again, not in standard form, my highest power is 7, so 7 is an odd number. And this is a positive 3.1. So that's going to go up from left to right. So on the right side, it's positive. Other side is the opposite, it's negative. So here's some last ones for you to try. You can either pause or end the video here. Answers are posted at the end of the blank notes on Google Classroom. And that is our introduction to polynomial functions.